Hello everyone, welcome back to my lecture sessions. In today's session, let us learn about propositional logic in AI. Under that, we will be learning what is the syntax of propositional logic and what is the semantics allowed. Okay, so first of all, let us talk about the syntax. The syntax of propositional logic defines the allowable sentences. What are the allowable sentences in propositional logic? What should be the format? Let us learn about that. So before learning that, first of all, let us see the types of sentences. So sentences can be categorized into atomic sentences and complex sentences. Atomic sentence means you will have only one single propositional symbol. Let us see. You will contain one single propositional symbol. Any statement, one simple statement, you will convert into, you will indicate it using a proposition symbol. Okay. Suppose a box is containing a set of balls. So a box of balls. So this I can denote using a proposition symbol or a chalk box. I can denote it using a proposition symbol. Okay, I'm a woman. I can denote it using a proposition symbol. So now one simple statement can be denoted using a propositional symbol. So that we call as an atomic sentence. And here each symbol stands for a proposition. Okay, so proposition is nothing but a statement which will have some true or false value. Always the statement should have some validity, true or false. Only such statements only we consider as a proposition. And symbols can start either with an uppercase letter. Usually we will use this notation just to differentiate it with from the regular letters. And this may also contain other letters as well, or it can also contain subscripts. For example, you can see P, Q, R. So all these are in uppercase. W, 1, 3. So here I'm using the subscript and I'm using the word not. Okay, so all these are valid propositional symbols denoting the atomic sentences. And also we should know about two propositional symbols which have fixed meanings. They are true proposition and false proposition. Suppose if any proposition is true in all the cases, always it is true, then we call it as a true proposition. False proposition is its truth value is always false. So then it is called as a false proposition. Then complex sentences. So coming to the complex sentences, this we will be forming from the simple sentences or from the atomic sentences using parentheses and logical connectives. So let us see an example. Here if you see W1, 3. So this is an atomic sentence or a simple sentence. P3, 1. This is also an atomic sentence or a simple sentence. So this we have connected using the logical connective and. We will be learning about this logical connectives shortly. And here I have also made use of the parenthesis. Implies negation W2, 2. Okay, so I have used three atomic statements here. So I have combined two atomic statements to derive one more sentence or atomic statement. So this we call as a complex sentence. So let us learn about the logical connectives. Okay, so first logical connective is negation. The symbol used for negation is this one. And this we can also call as not. Okay, so here is an example. Negation W1, 3. The next logical connective is conjunction. The symbol is this one. And we can also call it as and. Here you can see an example. W1, 3 and P3, 1. The name is conjunction, but while reading, we read it as and. Here the name is negation. Okay, so while reading, we read it as not W1, 3. The next logical connective is disjunction. You can call it as or. Okay, this is the symbol that we will be using. Here is an example. W1, 3 and P3, 1 or W2, 2. So here we have used the logical connective or. Then implication or conditional. The symbol is this. So this we can also call as implies. We may also use these two symbols as well. Here is an example. This we can also call as if-then statements, or we can call as implication rules. So here you can see this example, W1 comma 3 and P3 comma 1 implies negation of W2 comma 2. Okay, so here when you are using this implication, you have two parts, the left LHS and the RHS part. This LHS part we will be calling as premise or antecedent. The RHS part we will be calling as conclusion or consequent. The next logical connective is biconditional. This we can also call as if and only if. So here is the symbol. Sometimes this can be denoted using this triple equality as well. Here is an example. W13 if and only if negation of W2 comma 2. So now let us learn what is meant by a literal. A literal is either an atomic sentence. Okay, so it can be a positive literal or a negated atomic sentence, which we call as a negative literal. Okay, so literal is always an atomic sentence. So that can hold two values, either a positive value or a negative value. If it is holding a positive value, that we call as a positive literal. If it is holding a negative value, that we call as a negative literal. So now let us see a BNF form, that is Backus-Naur form, grammar of sentences in propositional logic along with the operator precedence. So here we have seen many operators, not, and, or, implies, by implies, or if and only if. So totally 5 we have seen. So we should know what is their precedence also, right? So for that, we have denoted using BNF grammars. So let us see, whenever you have a sentence, that sentence can be an atomic sentence or a complex sentence. So now atomic sentences can be either true, which holds always true, or it can be a false proposition whose value holds false in all the cases, or it can be P, Q, R, or W1 comma 3 and so on. Or it can be a complex sentence. The meaning of complex sentence is either it can be a sentence enclosed in parentheses or in square brackets, or a negated sentence, or sentences connected with and, or any of the logical connectives, and, or, implies, or if and only if. So now if you see the operator precedence, first highest priority is there for and whenever you are breaking down a complex sentence for its truth value. So first you have to apply the negation, and then you have to apply and, then or, then implication, and then by implication. Okay, so remembering this Baker's normal form is very easy, I guess now. So so far whatever we have discussed, the entire thing is described in these three statements. A very simple one. Next, let us talk about the semantics of propositional logic. Okay, semantics always defines the rules. In the syntax, we have seen what are the type of statements that are allowed. So now we should see how to use them. Okay, so this will define the rules for determining the truth of a sentence with respect to a particular model. In propositional logic, a model simply fixes the truth value. So what is meant by a model is either it will assign a true or false value to every propositional symbol. So that we are calling as a model. For example, if the sentence in the knowledge space makes use of the proposition symbols, say suppose P1, 2, P2, 2, P3, 1. So these are the propositional symbols we are using. Then what can be? So here each symbol should either hold a positive value or it should hold a negative value. So then one possible model can be P12 can be false, P22 can be false, P31 can be true. What is the other possibility? P12 can be true, P12 can be true, P22 can be false, P31 can be true. So anything, either I can make it as a true or I can make it as false. Okay. I will make this also as true. I will make this as false. So now I am getting one more model. Next time I will change. So like this totally how many models I may get? So here I have three symbols, three proposition symbols. So 2 to the power of 3, altogether 8 possible models I will get. Okay. So here each proposition symbol either holds a true value or a positive value. So two possibilities for every proposition symbol. Like that, how many proposition symbols we have? 3 we have. So total possibilities are 2 to the power of 3. So that means a combination of 8 possible models. So now how to compute the truth of a sentence, let us see. So for that, whenever you have a complex sentence, we will be using this truth table to compute the truth of the statement. For example, if P is false and Q is false, whenever you are using negation P, so P is false, so negation P should be opposite of it, true. Okay. Suppose if P is true, negation should be false. Then P and Q. So P and Q, if you observe, initially P is false, Q is false. So then its truth value is false. Then P is false, Q is true. So some people will also denote it as 0, 0. False is 0, true is 1. 0, 0, 0, 1, 1, 0, 1, 1. So this is also valid. Okay, so true we will be denoting as 1. I think already you might be aware of this truth table by this time, I guess. But if you are new also, you can learn. No issue. Okay. So at a time, only one bit we will be changing. So 0, 0, then 1, then 2, then 3. Okay. So let us decode it as false and false. P and Q will be false. False and true, it will be false. True and false, it will be false. True and true, it will be true. Okay. And in simple terms, P and Q will be true only when both the proposition symbols are true. Both propositions are true. Only in that case, P and Q. So both statements should become true when two people are agreeing. Okay. So when you and your friend both are telling true, then only a particular thing will become true. Otherwise, if any one of you tells false also, it will become false. So in this way, you can try to remember this. Then PRQ. Okay. So PRQ means if any one of you will tell the truth also, it will become true. If any one of you gives the correct answer, then it will become true. So that means P is false, Q is false. In this case, PRQ will become false. P is false and Q is true. So in this case, PRQ will become true. So that means only one is true, but the answer is true. So here P is true, Q is false. Then the answer is true. So here both P and Q are true. Even then PRQ is true. Okay. So PRQ in simple sentence, what you can, in one word, what you can remember is if any one of the proposition symbols are false, then PRQ will be false. Otherwise, it will be true. If both are false, then only PRQ will be false. If any one is true, then PRQ will be true. Okay. So then coming to P implies Q. So here we call P as the antecedent and Q as the consequent. So the result of this Q is dependent on P. Okay. So that means only whenever whatever P says, that will be true for Q. So that means here P is false, Q is also telling false. P implies Q. Yes, it is true. Again, P is saying false, Q is saying true. Okay, so its truth value is true. Then P is saying true, Q is saying false. Then its truth value is false. P is true, Q is true. So in this case, both are true. Next, coming to P, if and only if Q. So here in both the sides, it should be true. So here P is false, Q is false. In this case, P implies Q will be true. I forgot to mention the shortcut for this P implies Q. So for P implies Q, if any one is true, So here in the P implies Q, it is purely dependent on this Q. So only when Q is false, you can observe, only when Q is false, you are getting P implies Q as false. In rest of the cases, you are getting true. So when both P and Q are false also, you are getting true. When both P and Q are true also, you are getting true. Okay. When P is false, Q is true also, you are getting true. So here it is purely dependent on Q. So P implies Q. Okay. So then coming to P, if and only if Q. So then when both P and Q are false, it is true. When both P and Q are true also, it is becoming true. In rest of the cases, it will become false. So here P, so this we will be studying as P implies Q and Q implies P. So in both the cases, it should be true. So here you can remember this as only when both P and Q are true, this becomes true, or when both are false, this will become false. In rest of the cases, this is false. Sorry. When both P and Q are true, this is true. When both P and Q are true also, it is true. In rest of the cases, it is false. You have to by heart this truth table in order to compute the truth of a sentence. Okay. So for atomic sentences, true is true in every model and false is false in every model. The truth value of every other propositional symbol must be specified directly in the model. So other than this true and false, if you have any other value, that must be specified. Okay. So for example, here in the above example, in the model M1, we have given P12 as false. So like this, you have to specify. Hope you followed the lecture. If you have any queries, please let me know in the comment section. If you have, if you need any other topics also, you can mention me in the comment section. Thank you.